And we're back. We're going to go ahead and go through this example problem here, question number 1. And so let's go ahead and get ready to begin. So number 1, remember these are heat loss, heat gain questions. And so what we want to go ahead and do is we want to investigate here. We want to look at our problem and find out, is it going to be the case where heat is going to be lost, so heat's going to be leaving the house, or is it going to be the case where heat is going to be gained? So in this question, they end up telling us a wall has a width of 11 feet and has a height of 9 feet. The R value of the building envelope is 12.92. Now, as we can see, that's kind of a bit lower than numbers that we're used to. The outside temperature is 19 degrees Fahrenheit and the inside temperature is 82 degrees Fahrenheit. So what is the heat loss or heat gain in this scenario? Enter in the absolute value. And so for this question, let's go ahead and let's think about this. So the outside temperature is 19 degrees Fahrenheit, which means that it is winter time, right? In that case. So the inside temperature is a whole lot higher. There's a whole lot more heat. And what's going to end up happening is that heat is going to be trying to escape to get to outside. Remember, we always go from an area of high temperature to an area of lower temperature so that we can reach thermal equilibrium. So in this case, this is going to be heat loss, because heat is leaving the house. Okay, so this is a heat loss scenario here. Let's go ahead, let's begin. So we've got Q prime equals AU multiplied by delta T, where A is our area under investigation. It's the area of this wall, right? We also have U. Remember, U is basically how much heat is transmitted, and that's equal to 1 over R. So the U value, or the U factor, is equal to 1 over our R value. Remember, R value is how much thermal resistance there is. So that's how much heat we're able to stop from passing through a certain material. So the higher this number is, the better it is an insulator. The lower this number is, the better of an insulator it is. Okay. So last thing is delta T. Now in terms of delta T, we need to do the outside temperature minus the inside temperature. So if we end up with a negative value, then that's going to tell us that this is heat loss as well. If we end up with a positive value, that means that heat is going to be entering your house. Now, as we already said, though, we should end up with a negative value because this is a heat loss situation. Okay, so let's go ahead and let's begin. We've got the area here. So the area is, we've got 11 feet for our width. Remember, it's just width times height, and then that times 9 feet. And so if we end up calculating that out, you end up with 99 square feet, right? You could probably do that just mentally. Remember, you always can end up bringing up your good old TI-84 and punching those in there, right, to find out what those values are. But we know that. This next part, we are going to need to end up using the calculator, though. So this is 1 divided by 12.92 is what we've got here. And so we can go ahead and click on here, 1 divided by 12.92, enter. What we end up with is the following value, 0.0773. Now, be very, very careful. This is a 9 and then a 9 after that. It might be pretty, you might be wanting to round that up, right? Because especially the fact that those are both 9s. Remember, we do not ever round up our U factor. Okay, so it is 0.0773 is what we're going to end up going with. All right, now the unit for this, we do want to end up keeping track of our units because you're going to end up seeing in the next part here that these are going to cancel out really, really nice. So we got BTU over feet squared times degrees Fahrenheit times hours, or times hour. So that's our unit there. And then now for this last part, we want to do the change in temperature here. So now the change in temperature, it's going to be the outside temperature minus the inside temperature, right? So outside temperature for this scenario is 19 degrees Fahrenheit. So we're going to go ahead and put in 19 degrees Fahrenheit, subtract that inside temperature, which is 82 degrees Fahrenheit. And so now, just as we were talking about, if we end up with a negative number, that should mean that heat is leaving the house. And so we did end up with a negative number. It's negative 63 degrees Fahrenheit, right? So this is where you got to be very, very careful. On the Canvas quiz, they're going to be wanting the absolute value. So make sure you just insert the absolute value into there. But we do know that this is heat that is being lost. It's leaving the house, right? So keep that in mind. Anyways, Q prime equals AU delta T. Area under investigation is 99 square feet. Our U value is 0.0773. Now, as we were saying, we want to write down these units because just like we were talking about, it's going to cancel out really, really nice for us here shortly. We're going to multiply this by a negative 63 degrees Fahrenheit. Now, just as we were saying, these units are going to cancel out well. There's feet squared here. There's also feet squared underneath here. There's also a degrees Fahrenheit right here that's going to match with this degrees Fahrenheit over here, okay? And so now, let me go ahead and move this guy over. We can end up performing the calculation for these numbers. But what we end up finding for our units is the only units that are left is BTU per hour, which that definitely lines up because this is the heat loss or heat gain per hour, right? In this particular scenario, the heat is being lost though. So now what we can do is punch in our calculator 99 times 0.0773 times that 63. Now remember, this is going to be a negative number. So this is negative 482.12. Now, just remember, whenever you go to put this into the Canvas activity, because it says enter in the absolute value, you'll want to make sure you put in the absolute value, right? So we're going to end up putting into our Canvas assignment 482.12, and that is how we end up calculating out the heat loss for this question. Hope that was helpful. Happy calculating, everybody. Catch you all in the next video. Ciao.